Hello, I'm Davies. In today's talk, I want to continue talking about the Trinitarian equation with regards to time, something that we've already talked about. But in this time, I want to particularly look at the coefficients of the terms in the equation. We can see from the equation that the coefficient of each of these terms is unity, plus 1. And I wonder whether this is always the case. Clearly, for the real terms, plus t and the minus t, these relate to the time of the universe. Measures the time from which the universe was created, and therefore are pretty well unchangeable, immutable. But what of the imaginary time component? Well, I've looked at changing the coefficients here, and I've calculated the perceived time, capital T, and made a little chart, and it points to some interesting phenomena. If we start with a coefficient of 0, in other words, that is cancelled completely, we have no imaginary time, no dreaming, no imagination, no, thinking, then this term just becomes plus or minus the square root of 2 times t, which is 1.414. In other words, the perceived time is about 40% normal, of the normal time, the real time. In other words, time palls. As we raise the coefficient, we see that time palls less. The higher we go towards 1, the less time palls. In other words, things are not quite so bad. And when we get to 1, we achieve parity. As we rise above 1 and head towards 2, however, the situation changes, inasmuch as we now seem to feel that time isn't passing so slowly. We've all heard the expression, time flies when you enjoy yourself. Well, this demonstrates it, because by the time we get to a coefficient of 1.8, we can see that the time now seems 0.45. Time seems to have passed more quickly. For an hour, it only seems to be sort of like 25 minutes has flown during the hour. 2 seems to be a natural limit. When we get to 2, this equation turns to 0, which suggests that timeless. You're almost in a state of ecstasy. And so here we have it. If we raise a coefficient from 0 to 2, we seem to be going from a situation where we have almost despair, time seems to be dragging so slowly, rising up to the point where the time seems to go by in a flash. We have, in effect, a happiness index. But is there a more serious point to this? Well, I think there is, and it revolves around time dilation. We can't go above 2. That seems to be the natural limit. It takes us into the fairyland world of imaginary dimensions again, but we can go below 0. And I give 2 examples here, that if we have the coefficient of minus 100 in front of the imaginary time, then disregarding these terms as being relatively small, we get that the perceived time now is 10 times t. In other words, time really is going slowly. If we make this a minus 1,000,000, then the figure becomes 1,000. Now, are there examples in science of where time drags by so slowly? Well, I think that we might have the answer in the event horizon of black holes. according to theory, as we get to the event home, slow motion, everything happens in slow motion, almost time comes to a complete stop. And I think this is because gravity in some way affects time. Einstein thought that it did because increased gravity slowed time. And I think we have here another graphic illustration of how gravity, intense gravity, actually can slow down time. This might be a further reason or further work needed by real scientists. So come on out there, let's hear from you. Thank you very much.